Hello and welcome. I'm Bill Wake. We're working on a basic interpreter. We've tried to replace the whole parser with an evolutionary design. We've basically done that replacement, and now we're doing some cleanup because of the opportunities that created and probably a little duplication I introduced along the way. That's the way it goes. Okay. Let's see. So what we did at the end of the day was we started pulling out this TokenMatcher class. Actually, we call it Tokenizer. Where's parser? Syntax analyzer. We called it Tokenizer. I think TokenMatch might be a better name because part of what it's doing is providing the match functions. So let's start with, well, let's run those tests and make sure everything's green. Pretty sure we're okay. Okay, so let's rename this to TokenMatch. TokenMatch or Matcher. I think Matcher. All right, now let's see. We have the match one, and let's see. We had a couple of things where we're pulling stuff from here, and I think we can make that available here. Okay, yeah. So this calculation, that is all about Tokenizer. So let's just let Tokenizer give us the result. Okay, so I'll just make a method. And this is a line number, and it returns line number. Okay. That should be line number 0 just for consistency. And this tokenizer dot goes away. I don't know, this is kind of a non-standard tabbing for this, but I use it a lot. Okay, and that reference is analyzer. It's not the init, it's not the parse, there it is. Tokenizer dot line number. I don't know if we need parentheses there. Or line number. Oh, type line number. I forget how you get. I think that's all you got to do. Okay. Factor we renamed Tokenizer to TokenMatcher, and we extract and move method line number to TokenMatcher. All right. And then another thing I saw us do was token dot dot dot. Again, I think we can make a return value out of this. I'll just return those tokens. And again, I think we'll take this. This is column at the position. I don't know if that's an int. We'll have to check that. But this is an int coming back. Okay. Come at position. Okay. All right, now well, let's refactor. Okay, now I don't know if let's try and make this explicitly private and see if anything breaks. I suspect there are. Yeah, didn't take long. Oh, it's even in this file. Tokenizer.tokens. Ew, yeah. Now we need to update it. We can't create that at runtime because we needed to pass the tokenizer along before we started parsing. So let's make a. Let me see if anybody else complains, because I think I guess not. Okay. Let's just add a set tokens then. There'll be just sort of a setter method rather than direct assignment, just to kind of, I don't know. It may be arbitrary, but I feel like it. I feel like making it explicit is worth doing. Oh, init. I'm curious who creates this and what they pass in. TokenMatcher. Yeah, we don't need that. TokenMatcher gets set tokens method, loses initializer. Okay. That's good stuff. Now let's see who uses one of. We got match. Do we need match one? And I don't think we use one of either. Okay. All right. So let's extract this into its own file. And this is still part of the parser. TokenMatcher. Okay, now syntax analyzer, we defined the match function. We need to do the same thing in ExpressionParser. So match is there, and we want to pull that in. Okay, so this, whoops, TokenMatcher, this. Okay, so now we have that, and we should be able to delete this. Okay, we should be able to delete this. Okay, and let's rename this one to match one to match the other. And match one just takes a token type. Sorry, it's a function of token type, but no message. And it produces a satisfy token. Okay. Match one. And we'll do the same thing. And finally, one of. Wow. And I don't think I need the variable here. Okay, so we have those three functions. These should be fine. They should all work. Oh dear. Cannot convert any to expected token type. I think I copied that wrong. Sorry, TokenMatcher. One of. Oh, I didn't pull one of over. Okay. Let's get that. Make sure I didn't do that. Okay, I guess I did not. Well, we still have it in ExpressionParser, so I'll pull it from there. One of token types with a set. Statement parser. Array of token type and a string goes to satisfy token bang equals nil. Oh, still. Oh. Oh, how do you do that? Let's find the callers of one of. Okay, I think we're going to take that default away. Yeah, let's take the default away. I may be changing the messages a little. That one has it. That one doesn't need it. And this one's not affected yet. Oh, it is affected. Okay. May have a change in message. Found nil while wrapping an optional. Oh, did we not pass this? Oh, we didn't set it. Okay. Statement parser gets one of from Tokenizer. Oh, TokenMatcher, sorry. I'm going to take out the optional message. Sorry, it's still there. It's just not optional. Okay, we did statement parser. Let's look at expression parser. We'll need those same three functions. And those same three lines. Now, okay, this should still run. These become match ones. So I can delete that. Actually, I can delete that too. One of is going to break because we're not providing a message anymore. Okay, so we'll take the message off, drive it to be similar to the other one. It's going to be one or two places. Well, I guess 4 places. Okay, one of relops, expected relational operator. Ooh, what's the matter there? Okay, that just had follow-ons. Okay, so that should be okay. Now the tokenizer one should do the job. Okay. Let's see. I should keep my to-do up to date. We did that. Make match, match one, move one off to tokenizer. Okay. We did that. Move one up to tokenizer. Yes, we did that. And we did that. Okay. Let me see. We're going to walk through this thing and just kind of look how it's shaping up. Okay, so the make statement parser is going to build us a parser for all statements. Okay. And that's okay. I think that all is looking good. I mean, it's just sort of standard grammar stuff. It's a little funniness. Okay. Yeah, this is a problem. Okay, let's say handle if prefix better without backtracking. Okay, because the way this is, it tries if prefix both times, and our parser does do backups. You know, it will roll back and handle this, but I would rather not make it go through that, because this is like if expression. You know, that's a lot of stuff. Okay. That'll require some changes, I'm sure. All right, but we'll keep going. All right, that looks okay. Print parser. Okay, read. Then everything. Okay, simple statement. This I would like to get rid of too. This is my to-dos. Variable should know their type at the token level. We may not address this in this branch. Check the def, require float type. Okay, require matching types. All the makes. One of these was bugging me. What was it? Let's make sure the checks follow the new style. That's what it is. Okay, so it produces a parse result, so that's a good check. That's a good check. That's a good check. And I still feel like there should be a way. Yeah, I would love it if I could genericize this a bit, because like this is the interesting part. Everything else is kind of generic. Well, this isn't. Those two things, the condition and the message. I'd love to pass in something that gave a Boolean expression. Okay, dim info, parse result. Most of these are producing parse results. This one is not. Oh no, it's producing a statement. Okay, that's okay. That's okay. All right, those all look good to me. All right, expression parser. So we're getting to the end of the changes I had planned. So let's see. Did I check in? No, I did not. Okay. This was make expression parser use TokenMatcher's match functions. I probably should run tests one more time. Okay, now this make, okay. Did I call this make statement parser? I think we can call it make here as well. So you're saying statement parser dot make. I think that's reasonable. All right, expression parser. Okay, so numbers, integers, strings. Okay, predefined functions. Okay, so we're working our way from the bottom up. Here are all the factor stuff. Okay. And then these all are very similar. They match the operators and make an expression. Okay, I wanted to check out this thing. Okay. I was worrying about did I do a reduce here, but I did. Okay. Oh, also, is there a check unary expression? Oh, we require float type here. Match not. Require float type. That one's okay, but where's the other make unary? This one. Okay, we split this so it can require a float type here, and we don't have to do anything. That's good. Okay, this make numeric is a little crazy, doing crazy work. Look how big it is. Um, it's really trying to type check and compute. And yeah, even here it does the compute as part of it. But I don't know. This feels like a lot of work. Yeah. So, yeah, I don't think it's not wrong. Okay. It's if you don't have any pairs, then you just have a simple expression and it could be a string. If you have pairs, then you've got operators like plus something, minus something. And if that's the case, then that first number really does have to be a number. Um, Now, first index. I don't know. Maybe I could. I don't know. I was trying to think of a way to fold these two together, but this is correct and this is correct. If there is a failure, then we got a type mismatch. The other way I have in mind, well, I got a couple ways. One is I could do this. I could do the checking when I'm building the operators, and the result of op2, I could have something that checks that the left and the right are both the correct type, and if not, I would set the type to something different. So I could let my operator expression include the type of the result, which seems pretty reasonable actually. And if there were an error, then there's some sort of error type that says, type mismatch, and maybe tells us like the leftmost operator, or yeah, the leftmost operator that screwed up. Um, that would be more on the expression side. Or I could go through and, well, that's kind of what I'm doing here. I guess that's not really different. Okay, this way is different. This way, I was going to try and do something with the pairs, but I don't really need that. Okay. Um, okay. So, all right. Let's go back and keep our path through here. Okay. That recurs a lot. The other thing we thought about doing was you could use a different kind of parser here that knows the precedence of the operators and whether they're unary or binary, and um, let that do the work. But I don't want to take that step. I mean, it's kind of crazy. I have to do it this way. You get so many levels. It'd be nice to just say factor, operator, factor, repeat, um, or factors separated by operators. But yeah, that's not quite what we have. Okay. This is what I'm talking about. this check predefined, I'm actually jumping forward to this. Okay, expression parser. Let's find usages of this. Right, this operator, this less than ampersand bar, I think that might be the only use of it still. Let's just find text. Oh, these two uses. Check predefined call, check user defined call. Okay. So I would like to make those more like these. Okay, where it takes an argument and all that and returns a parse result. Okay, so let's try and do this. Gosh, this looks like a lot of junk, doesn't it? Token result type. Okay, so the token is a function. Okay, maybe we can simplify this. Function check predefined call takes an argument of these types, has a remaining array slice. Okay. And well, let's just pull it in and munge it around. Okay, we'll peel this apart. Expression and tokens. Should just be expressions. And this should be a token. Okay, token, comma, array of expressions. Yep, int string. Okay. That remaining. Okay. What are all your complaints? Okay. All right. So if well, result type of type. Okay, it's a function of arguments to type. Okay. Okay, this is, I suppose, a failure, but it really is a can't happen. Excuse me. Okay, so a failure just needs a token and a message. So let's get the token and a message. Unfortunate. All right. Can I convert token to expected type index? Okay, so that is index of token. Can I find index of? Okay. Well, same deal. Expression parser, if it wants index of, which I guess it needs. Yeah, it would be better if it had that index. Okay, so let's define that up here. Type is that. And let's rename this to TokenMatcher. Okay, now we don't need to say tokenizer.indexOf anymore. And we're in this one. Okay. All right. So we try a type check. Oh, and that also returns an error. Ugh. Let's find type check. Throws. Okay. We'll fix that one too. Okay. Let's see. So given the way it is now, though, we try that. If it succeeds, what are we returning? We're returning argument, I guess. Dot success of argument and remaining. Okay. If it fails, return index of. Okay, if we get a parse error, then this is a failure. Errors in arguments. Okay. Otherwise, this one's also a failure, and that's the one I want to get rid of. Okay. Success, parse result. Cannot convert token expression to expected argument type expression. Oh. Okay, and let's find the text because we're actually after this one. Okay, it is supposed to produce the same thing it got in. Okay, so I would say this can now switch to our other operator, which is kind of the mirror image. Okay, so that should use the new one. And this one is now unused. Predefined call. And user-defined call. Okay, but we've replaced call with parse result approach. And we need to fix this one. Okay, I'm just going to do the same kind of thing. Check. argument is token expression. And the result type is token expression. This is shorter. Okay, do a type check. If it's a failure, return that. And that's a failure. And this is a success. Argument and remaining. So it feeds through the pipeline. Okay, and let's flip this. Bar ampersand greater. Okay. And then this type check thing. Well, let's keep going. These are producing direct types. That's got parse result, parse result. Parse result. This one sticks out as not conforming to that. Okay. What would make this work better for us? Well, this is really, I don't know. I almost would be happier with an optional string. We get the token back. That's worth something, isn't it? Okay. Is that the token we get back? Okay, we're getting back the token we came with. Okay, let's let this thing return string optional. Unexpected non-value. That doesn't seem right. Unexpected non-void return value in void function. Let's do a clean. Unexpected. Oh, how weird. Unexpected non-void return value in a void function. I assure you, it's not a void function. What if I did this? Return. What is going on? Oh, this thing. Oh, yoy. Okay, the return there is coming from the closure. So we match the parameter types and the arguments together, and then if they're incompatible, maybe I gotta do a find first. First where in that is there a map or else? Evaluates the closure when the optional is not nil, passing the unwrapped value as a parameter. Okay, that may be okay. Map it to type mismatch. And then return result. And this is string optional. Okay. So basically, if you find one. Let's make sure this works. I may be mishandling the nil. No, okay. All right, so, oh, I don't call this yet, so can't tell. All right, so I'm zipping the parameters and arguments type together. I'm finding the first pair where it's incompatible, and I'm trying to map that result to type mismatch. The way map read, I assume it's saying optional turns into, if it's nil, it's nil. Otherwise, it gets mapped. Okay, but let's try this thing. I think I still have, nope. Let's look for type check. Okay, we'll do this one first. Let's do let error message equal type check to token parameter types token parameter types optional arguments. Okay. If error message is nil, then we're going to do our return success. Otherwise, we're going to return a failure with token and error message. All right. Can I convert token to expected type int? Oh, that's index of. All right. I think that's better. The optional is a little weird, but I don't know if this would be better flipped around either. Okay. Type check 2, same deal. Parameter types and so on. Token dot number and expr. Token number expr. Okay. This stuff is not getting done. And then, okay, let's go here. I don't think we use token. Oops. Yeah, we don't use token. Okay, so let's take this out. Type check 2 no longer needs token. Okay, and now we're not calling this anymore. So we can delete this. And we'll rename this run. Okay, and so we convert type check to just return string. And I don't know, no, we already fixed the predefined. Okay, good. Step was a little big, but okay. And then I think we've seen everything else. Okay, so we got rid of this. Okay. And reorganize tests. Okay, tell you what, we're due for a break, but we'll come back and handle if prefix without backtracking, and then do these test reorganizations. And I think, yeah, I think the rest we'll save for another time. I mean, they're sorry, we'll fix these two things. I assume we'll have a little time left, and we'll look at the error messages. These other things, I think, are probably not part of this project, so we'll skip some of them. But I think we'll at least start improving our parser combinator. Kind of go back to that project. All right, so see you in about 3 minutes. Okay, welcome back. So what we want to deal with is the if prefix here. Notice that it's happening in both cases. Now we need maybe it's, I don't know. let's write an alternative and see how it looks. Okay, if parser 2. Okay, so I want to pull this out. If prefix and match one integer max one integer or statement parser and match one colon. Requires the types check to Okay, well, right. So the requirement is, well, this fragment is what gets fed into make if go to, and it wants the if prefix as well. So that, and oh wait, I'm not sure the level of that pipe. Let's do it like this and make sure it's not going to matter. Okay, still not happy. Cannot convert value of type expression token to expected argument type token array slice of token. Right. Okay, so we were getting the expression and the token. Expression token, array slice token. It reads backwards because it's really this. Blah, blah, blah. This is token, array slice token. expected argument type. Token target is token. Array slice of token input is array of token. Right. So we're expecting expression in token because we want the prefix which yields the expression here. The if such, if x equals 7, that expression. But all we're getting in here is the integer. Okay, so maybe I don't have a good way around that. Yeah, the problem is going to be, if the prefix matches, then it looks like we're in there pretty good. Okay. How can I feed that? I guess the only thing I can think of is like some sort of intermediate type that holds integer or statements. Which is a little awkward. And then at the end, I can peel that apart and make one decision about which kind of statement it is. I don't think I can. Well, okay, how would I do it? I would, instead of make if go to, I'm going to transform it into, sorry, I'm going to map it to $0 empty list. Now that's going to be confusing. And I'm going to have to make a type, I think. I was going to pass the pair back of the integer and the array of stuff and let each one be empty. But that won't work. Let's see. I don't know if I can define it. I guess I can define it up here. Enum, then target, case, line number gives us a token, or statements gives us an array of statement. Like that. Okay. So now this maps to then target dot line number $0, and this maps to then target dot statements $0. Maps to the statements. Okay, so Argument passed to call it takes no statements. That doesn't seem right. Statement parser separated by colons. Okay, so that should give me a list of those. My parens are getting all messed up here. Okay. This doesn't need parens. Or oh, I guess we do need parens here. Okay, that's that one. This one. Or statement parser, this, that. Okay. And then right, and that is extra. Okay. Yeah, I don't know. All right, well, how this will work, we got the prefix. We either match an integer and produce a line number target, or we match a group of statements and produce a statements target. And if that all comes together, we do make if then, which is kind of a combination of both of these. Make if then. Why are you so weird? Excuse me. What? Excuse me. Okay, I think that's a better reason. I hope it messes up these less. Excuse me. Make if then, and the argument is an expression and a then target. Followed by remaining. And it produces this. Okay. So, well, let exper then target equal argument. Switch then target case statements let, well, let's do that one first. Case line number let token do something, otherwise it's let statements do something, and we know this is that. And where's my other make if? Oh, this one. This is that. Expected. Yeah, me too. Oh, now what's your problem? No make then candidate produces and then array element whatever, aka expression. Produces the type. Where'd my token go? If prefix and, that should be all this. Well, this piece should produce a then target, and this piece should produce a then target. Okay. Or else pipe satisfy token and a then target. Statement parser then token statement. And then array element. Well, if prefix, let's check the type. Okay, and then keep left only keeps the left piece, so it doesn't wait. Match the if, keep the right, which is ExpressionParser. Keep the left, which is ExpressionParser. So this thing should be a valid expression. Okay. Check to pipe satisfy token to statement.then target. Okay, so that should be a statement.then target. Keep left behind whatever statement parser.then target. Ampersand cannot be applied to okay. I don't see why not. And then this, it shouldn't be an array then element. Okay, we had this before. And then tuple of P1, P2. Well, P1 is if prefix. And P2 is this bit. Cannot convert value of statement parser then target to closure result type array slice of token. Cannot convert to closure result array type of token. That does not make sense to me. I mean, match one produces a token. Okay. That seems Match one produces a token, feeds into target line number, and which should take a token. Cannot convert value of statement parser then target to closure result array slice of token. Okay, let me find another one of these. I mean, that just takes a token. I mean, it gets the variable and it pipes that token into $0 and creates a next statement. Okay. I feel like I'm confused somewhere. Control, command, left arrow. Maybe I didn't do that. I don't know. Okay. Cannot convert parser.then target to closure result type array slice of token. My parens here. This should be, oh, maybe I've got the wrong arguments on this. Antipole P1, P1, P2. We did it up here, function variable and a parser. Okay, let's pull out the let if target equal this stuff. Okay, so it's that or that, and the target type, or else the pipe is the second type, which should be then target, a pipe, which the second type should be then target. So I think this thing is a then target. Okay, it fixed the and then tuple complaint. Interesting. Cannot convert expression then target array slice parse token to expression and then target. And then tuple, that's progress. It was that array thing. Check 2. Okay. Pine token expression satisfy. So this should be expression then target. Sorry, and then keep left, and then keep right. Expression. Okay, the keep right gives us expression. The keep left gives us expression. Okay. Expression with Well, my or else should give me a then target. Satisfy the then target. That closes the pipe, so that should be a then target. Expression statement then target produces parse result token statement. AKA expression then target. Okay, I don't know. Reading these nested type things is just the crazy part of all this. Okay. Expression then slice then target. Am I missing array slice of token? Oh, okay. I am missing an array slice somewhere. Is this function messed up? Remaining array slice of token produces parse result token statement. Over tokens producing statements. Argument, expression, array of statement. Argument, expression, then target. Yeah, that should be fine. Remaining array slice. Expression target. That part is right. Okay, make if then. I feel like I'm close, but I just am not seeing it. Okay. Expected argument type. And then tuple. I wish it would match parentheses here. It must be the quote, right? This whole thing. Yes, I've messed up something. Let's see. Make if then. They're the different kind. Okay. Yeah. It's actually a simpler transformation. Make if statements. Right. This thing just produces statement. And we don't need the remaining. We're just trying to turn one value into another. So, sorry. Okay. Expression and then target convert into a statement. Okay. And so we don't need a success. We just need to return this. And that was what it was telling me, but I just couldn't read it, make sense of it. Okay, that should build. If I go back here, and this is if parser, I'm going to make this if parser 2, and make this if parser. Okay. And that will attempt to use our new parser. Run tests. Okay, now I'm going to take if parser 2 out. Okay, so what we did was we remove oh, what's the phrase for that? It's a common prefix. Okay, there's still some more cleanup we can do on there, but let's capture what we got. Okay, so now I wonder if this will work now. So if I say if prefix and if target, pipe that to make if then. Because sometimes when the types are so messed up, it sounds like it's the first type, but it's not really the issue. Okay. Oh, boy. Now, I don't think this is actually bad, separating them like this. The prefix and the target. Okay. Yeah. All right. And then we don't need, we got some dead code. Make if statements is no longer called. Okay. And make if go to is no longer called. So we use and rather than and then tuple, and we eliminate dead code. Okay, and then that's good there. Okay, so handle if prefix without backtracking. We've done that. Reorganize tests. We just take another look around or statement parser. Where was that and then tuple? Maybe I messed up something there with the same kind of deal. And then tuple function parser. Okay, let's try this. So that is function parable and good. Okay. Good. Okay, let's okay. Again, I was probably messed up on my parentheses or something and confused it. Okay. Let's see. Reorganize tests. Oh, well, I should make sure that works and check that in. Okay. Reorganize tests to statement tests and expression tests. Well, we have those two classes here. Oh, we don't have a statement test. This was parser tests. Is mostly statement tests. Okay. I'm pretty sure expression tests are going to be expression tests, but I think some of these are probably expression checks too. So who calls this? That seems like a pure expression test. This seems like an expression test. Check error. Okay. Can't. Yeah, those all seem like expressions. Predefined function. Mid-dollar. Well, actually, I almost could make function tests. Okay, dim statement is not. These are all expressions. Expression test. Check expression. Okay, let's pull that over. I think all those should go over. Now, did I get them all? Seems like somebody should still be complaining. Cannot find check error. Okay, I'm going to take that duplication hit. I don't mind having them, well, I mind slightly having them identical, but I don't think that's terribly wrong either. Check one statement. What are you? Oops, sorry. Check one statement. I guess I'm happier having the duplication, but you can look at it within this file and see that it does something. I don't know, that seems okay. All right, let's run these. They all should run. Let's see if we got any other expression-y sounding things. Print. These are all statements. Assignment read. What about these? String can't do arithmetic. I would say that's an expression issue. Operators. Okay, let's put that here. define as much messages. These really are expressions. That was my ramblings left in for no good reason. Okay, and then test shall run. All right, we've moved those methods. And then these statement ones, I'd kind of like to put them in more or less alphabetical order. Okay, so line numbers ends. Well, that's the end statement, but the line number is actually more of a line number test. Okay. Well, I know end comes after print data. Now, the reality is we developed print very early because we were using it all over the place to check stuff. But I don't have to have my test order reflect the development order. Okay. They can test the order that makes sense for them. Or I want to test the order that makes a good story. No line number. Okay. 10 rem. Well, I think I'm going to make this valid line number. And then test line number must be in range and no line number. Multiple statements on a line. Okay, now these print statements. Semicolon, comma, yes. And print goes down here a ways. There's another print. Okay, let's put them down here. Let's see, somewhere there's a fold. Editor, fold, everything. Functions. Yeah, that's what I'm talking. Okay, line numbers, data, and go to if input assignment statement. I could probably call I'll move those below the let. They're kind of a shortcut. Print. Read. Oh, def comes early. Def. Predefined functions. Let's see what that's about. That sounds more like an expression. What's this? Okay, this is These four are actually kind of a different thing. They're not they're really checking that we count the number of statements correctly, and that's because the way if statements can have multiple statements on a line. We needed to make sure like a go sub returns and goes to the next sub piece and returns and go to the next sub piece, and then this one should go inside the if statement, and it's like nesting in. So it's a complicated situation because of the way we handle go-tos and ifs and go subs. Because go sub can return to the middle of a line, and that's kind of a weird concept in BASIC. The old BASIC didn't have the colons to let you put multiple statements on a line, so it didn't have this issue. Okay, but I think that's good. Let's make sure they all pass. Okay. Now, expression tests. I don't feel as inclined. Let's make this a 2-2. I'm not as worried about making them unique or organizing them in the same kind of way. All right. I will call that a wrap. Okay. And our to-dos is reorganize tests. Okay. Now, can we improve messages? Okay. Let's see if I can. Where's the syntax analyzer? Oh, parser tests. Let's rename those to statement tests. Or at least parser statement tests. Okay. 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 All right, let's see if I can get to the issue here. We need statement parser. Okay. What happens? There's sort of a question of backing up. Let's see if I can find one of these. Yeah. So here's the for statement. It's for variable equals expression to expression, optional step expression, and turn that into a float type. And the problem is, if you, this optional thing, if you match this far, you sort of should be committed to a step statement or the step substatement. But because the way the parser works, it says, well, it's an optional match. So if it doesn't match, even if it doesn't match because you got a step but no expression, it's like, it doesn't match at all as far as I'm concerned. And it just says, okay, skip it. And so we end up marking the step statement as like extra characters at end of line, even though we had the word step. And so we know from the outside, not from this code, but we know that it ought to be regarded as failing in that place. Okay. Then the second place of failures, let's find this. Yeah, where we just had one of these. Okay. The if basically the or here, the current implementation says, I don't care how far you got. If you messed it up, I'm just going to go back up all the way and then try the next branch. Okay. So let's see. We can see this mostly on statements themselves. That's a better place. You got assign data and so on. Okay. And so what happens is if you start down the path of, say, a for statement, for x equals 1 to 3, blah, 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 blah. Okay. It would be simpler for me to say, oh, well, you started matching a for statement. You must, you're committed to that now. And not want backtracking. It's like if you got for whatever, for x equals 1 to 3, or x equals 1 to string, quoted string, okay, you'd like to say, don't try go sub, go to, all that stuff. We already know it's a failed for statement. Okay, now the way that or bar works in the current code is it finds which parser got the furthest and it takes that one, but it backtracks, and so it can end up backtracking past every combination and not really recognizing that it was I don't know, how do I want to say this? It backtracks, so it just gives up and goes on to the next one, and so on and so on. The reading I've been doing on the parser combinators, there are maybe circumstances where that's the one you want, but most of the time what you should do is say, like, if you got partway down the branch, that's, you're in the, you're dealing with the right thing, and don't retry every other parser. They're not going to match, just the way we organize the grammar and so on. And so my proposal and plan is, I want to change the default on this or bar and on the question mark and make it kind of a three-way branch. So if you succeed, all is good, you succeeded. If you don't even match the first thing in it, then yeah, go on to the next parser. But if you get partway in, then just stop there and say, I found my error here. And I think that will improve most of our stuff. Okay, so I'm going to switch. Let's see. Can we improve messages? Well, yes, we can, but I think we need an improved library first. All right. All right. Thanks for joining, and I hope you have a good weekend. Take care. Bye bye.